Hi, in this video I'm going to show you how to solve simple quadratic equations at GCSE Maths level using completing the square. Before we get started, please click the subscribe button and the bell icon. That way, when I put out videos on topics related with GCSE Maths, you will get notified. In previous videos, I showed you how to solve quadratic equations by factorisation and by using the quadratic formula. I have linked to those videos in the description. Now, let's look at an example of how to solve using completing the square the quadratic equation x squared plus 8x plus 3 equals 0. Remembering that the standard quadratic equation is of the form ax squared plus bx plus c, we first need to identify what the values of a, b, and c are. In this case, a equals 1 because 1 times x squared is x squared, b equals 8, and c equals 3. The next thing to do is take the value for b and divide by 2. We will then add this to x and square. In this case, b equals 8, so b divided by 2 or over 2 is 8 over 2, which is 4. We then write x plus 4 squared. Now we need to add another number onto this. If we were to multiply out x plus 4 squared, we would get x squared plus 8x plus 16. But we originally had x squared plus 8x plus 3. The difference between the last two numbers is the difference between 16 and 3, which is 13. So x plus 4 squared minus 13 is the same as x squared plus 8x plus 3. So we haven't really changed anything mathematically. All we have done is change the format of the equation. However, what is good about this format is it's easier to find the solutions to the quadratic equation x squared plus 8x plus 3 equals 0. So we add on 13 to both sides of the equation x plus 4 squared minus 13. We then get x plus 4 squared equals 13. We can then square root both sides and get two possible answers. X plus 4 equals positive square root of 13, or x plus 4 equals negative square root of 13. Using the calculator to find answers to one decimal place, this gives two answers, minus 7.6 or minus 0.4, both to one decimal place. So we have now seen how we can find the solutions to a quadratic equation using completing the square. Reviewing, first we find the values of a, b, and c, which correspond to the values in the standard quadratic equation ax squared plus bx plus c equals 0. Then, if a equals 1, we divide b by 2 and add to x, and then square to get the first part of our result. So you will get x plus something or x minus something, whole thing squared. This will give us a quadratic expression or equation, the first two terms of which will be the same as our original expression. However, the third term will probably not correspond. So we have to add or subtract a number which gives the correct value for the third term. We then solve this equation by rearranging, so we have the square part on one side and a number on the other, and then we square root both sides to get the two solutions for x, which solve the original equation. Now let's look at an example where a, or the number next to the x squared term, is greater than 1. Let's find the solution to the quadratic equation 2x squared plus 3x minus 5 equals 0 using completing the square. This is probably about as difficult as you're going to get in the GCSE exam. In this case, what we can do is divide the value of b by not just 2, but 2 times a, which in this case is also 2. So we divide b, which is 3, by 2 times 2, which is 4. So we get the fraction 3 over 4. We now add this 3 over 4 to x and square. Then we multiplied this square term by a again. So in this example we have x plus 3 over 4 whole thing squared times a, which is 2, or 2 times x plus 3 over 4 whole thing squared. We now have part of the answer. If we multiply this out, we get 2x squared plus 3x plus 9 over 8. But we originally had minus 5 on the end. 2x squared plus 3x minus 5. Now minus 5 expressed as an improper fraction is minus 40 over 8. So to get our original quadratic, we need to subtract 49 over 8 from 2 times x plus 3 over 4 squared. Again, as before, we have only changed the format of this equation. If we were to multiply it out, we would get 2x squared plus 3x minus 5. But now the objective is to get the two solutions. So we will solve this equation by rearranging. We will add 49 over 8 to both sides. This will give 2 times x plus 3 over 4 squared equals 49 over 8. The next step would be divide both sides by 2. This will give x plus 3 over 4 squared equals 49 over 16. The next step will be to square root both sides. This gives two solutions, because as we know, any square root has two solutions, a plus and a minus solution. The square root of 49 over 16 is 7 over 4, or minus 7 over 4, because the square root of 49 is 7, and the square root of 16 is 4, or minus 7 and minus 4. So x plus 3 over 4 equals 7 over 4, or x plus 3 over 4 equals minus 7 over 4. So taking the first equation, x equals 7 over 4 minus 3 over 4, which is 4 over 4, which is 1. And taking the second equation, x equals minus 7 over 4 minus 3 over 4, which combining gives x equals minus 10 over 4. Thus, using completing the square, we have found two solutions to the quadratic equation 2x squared plus 3x minus 5. So to review how we deal with solving quadratic equations where a is greater than 1. First we divide b by 2 times a. Then we add to x and square. We then multiply this by a again. We then multiply out and find what number we need to add to or subtract to the resulting quadratic to get the original equation. We then write out the squared term multiplied by a and add or subtract this number and put the whole thing equal to 0. The next step is to rearrange the equation and solve to get the two values for x, which are the solutions to the original quadratic equation. In this video, we looked at how to solve quadratic equations using completing the square. I have a question for you. If completing the square now makes sense to you, please put yes in the comment box. If not, please put no. Thanks for watching, and please like or share this video if you found it useful, and don't forget to subscribe to this channel. Thanks and bye for now.